Hello everyone. So this class we are discussing on the topic Dissolution Controlled Drug Delivery System. In our previous sections we have discussed what are the various controlled drug delivery system, what are the various rate of the processes, etc. So let us discuss first on the classification of controlled release drug delivery systems. So this control drug delivery system can be have various different types of classifications. Now here we are discussing based upon the release of the drug. It can be classified into three, that is rate programmed drug delivery system, stimuli activated drug delivery system, and site targeted drug delivery system. Now, what do you mean by rate programmed drug delivery system? So, from all these three sentences itself, the three classifications itself, the concept is very much clear. Rate programmed drug delivery system. We are discussing on the controlled release drug delivery system. That means the release of the drug from the delivery system must be in a controlled manner. It should follow a zero order rate. Now, for developing this, we have the method or we have a type called rate programmed drug delivery system. That means the rate at which the drug has to release from the delivery system is pre-programmed. It is programmed or it is designed within the system. It is programmed within the delivery system. That means the delivery system is developed in such a way that this will release the drug at a constant rate, at a prefixed rate, at a rate fixed at the time of designing. What is the rate fixed? At that rate only the drug will be released from the delivery system. So such type of systems we call it as a rate programmed drug delivery system. The second classification is stimuli activated drug delivery system. So in this type of drug delivery system, any type of stimulation, the stimulation can be physical, chemical or biological or any type of stimulations. So once there is a stimulation, based upon the stimulation the delivery system gives a response. Delivery system gives a response for the stimulation by releasing the drug. That means for a delivery system to release the drug molecule, it should get a response. Once it received the response, once it received the stimulation, based upon the stimulation, it releases the drug molecule from the delivery system. So the stimulation can be within our body or it can be a mechanical also. So various different types of delivery systems has been designed based upon this principle, that is stimuli activated drug delivery system. Either the delivery system itself can stimulate or based upon the various concentration of endogenous substances or based upon the physiological conditions of our body, there can be stimulation for the drug delivery system, and based on this stimulation it may releases the drug from the system. The last one is the site targeted drug delivery system. These are the delivery system which releases the drug in its target site. Where is the site of action? At the site of action this releases the drug molecule. So these are the type of controlled release drug delivery systems based upon the release of the drug from the system. Now, first let us see rate programmed drug delivery system. The rate programmed drug delivery systems are classified into four different types. That is Dissolution Controlled Drug Delivery System, diffusion controlled drug delivery system, erosion controlled drug delivery system, combination of dissolution, diffusion and erosion controlled drug delivery systems. That is, the first we have discussed what is pre-programmed drug delivery system. The delivery system, while developing the system itself, the rate of the drug is pre-programmed. Now, on what mechanism or what basis the release is being programmed? So, based upon the mechanism, this rate programmed drug delivery systems are classified into four. In the first one, the dissolution controlled drug delivery system. So here, the dissolution, controlling of the dissolution is the mechanism. Dissolution, it is the movement of or the transfer of the solute material into the solvent system. A mass transfer of solute into the solvent system. This we call it as the dissolution. So once there is a dissolution, more amount of drug will be reached into the GI fluid. In the last class, we learned two different types of control release drug delivery system. That was release system developed based upon the reservoir as well as based upon the matrix system. The reservoir system, we have the core tablet is being coated with any of the rate controlling polymer, and the rate controlling polymer act as the reservoir membrane. Inside the reservoir, the drug molecules can be freely moved. Inside the reservoir, there can be easy transfer of the drug molecule. So this can be achieved in case of a reservoir system. Whereas in the case of the matrix system, the free transfer of the molecules are not possible within the system. It is being restricted by the matrix material. Now, irrespective of the matrix or irrespective of the reservoir system, the system can be a dissolution control where the dissolution of either the dissolution of the drug is being controlled or the dissolution of the polymer matrix is being controlled. So the dissolution control delivery system can be developed by controlling the dissolution of either drug or the polymer or the membrane. Anything, the dissolution can be controlled. So if we control the dissolution of any of this, we can achieve a control release drug delivery system. The second class is diffusion control drug delivery system. Diffusion, you know what is diffusion. It is the penetration. It is the movement of the drug molecule across a membrane. So in case of a reservoir system, the core tablet is coated with a polymer membrane. The core tablet is coated with a polymeric membrane in case of a reservoir system. So what happens? The drug what is present inside the core has to diffuse across the membrane. One thing. Second thing, in order to dissolve the drug what is present in the core, the dissolution fluid or the gastric fluid must penetrate the reservoir membrane, and this gastric fluid must enter into the core. Once the gastric fluid enter into the core, the drug will dissolve within the gastric fluid and the drug may penetrate the reservoir membrane and it can come out of the drug delivery system. Just listen. If you have administered a control release drug delivery system made as a reservoir system, It has a core tablet coated with a reservoir membrane. Once you have taken the tablet, after reaching the stomach, slowly the gastric fluid starts imbibe or diffuse into the delivery system. The delivery system never disintegrates. It remains intact as such. Slowly, the dissolution fluid penetrates the diffusion membrane and it reaches into the core of the tablet. After reaching the core of the system, it dissolves the drug molecule within the core. Now, some of the drug molecules exist in the dissolved manner or solubilized manner. Some are still existing in the solid state itself. The drug molecule, what is dissolved, slowly can penetrate the diffusion membrane and it can move from the delivery system outside the delivery system, from the delivery system into the gastric fluid. So, there is the diffusion of the gastric fluid, at the same time diffusion of the drug across the membrane. These two parameters are being controlled in the diffusion controlled drug delivery system. The third one is the erosion controlled drug delivery system. So erosion is defined as a physical disintegration of a polymer wax or polymer material as a result of degradation, and it is characterized by material loss from the polymer generally in the physical state. So simply, if you say erosion, something is eroding. Suppose if you have a tablet made of a polymer matrix, the polymer matrix is being eroded from the delivery system. A small portion is eroded, a small portion is eroded out of the system. Such type of system, we call it as an erosion system. So, in this rate programmed drug delivery system, the third classification is erosion control. That means the process of erosion is controlled. Erosion of the polymer is controlled. That means there is no erosion, or the erosion happens at a slow rate. If the erosion happens at a slow rate, the drug release also happens at a slow rate. So the third classification is the erosion control drug delivery system, and the last one is combination of all these three, that is either dissolution or diffusion, or it can be erosion also. So by combination of any of these mechanisms, we can design a rate programmed drug delivery system. Now, our topic of discussion is dissolution controlled drug delivery system. So let us discuss first on the dissolution controlled drug delivery system. Now, as we discussed, the dissolution control, it can be because of controlling the dissolution of the drug molecule or controlling the dissolution of the reservoir membrane or the matrix. Now, our target is to develop a pre-programmed controlled release drug delivery system. For developing a pre-programmed controlled release drug delivery system, we have different mechanisms. Out of that, one mechanism is dissolution controlled drug delivery system. And the dissolution controlled drug delivery system, the delivery system that works under the principle of dissolution control, may be based on the two things. The first one is the controlling the dissolution of the drug or controlling the dissolution of the polymer membrane or the matrix. Any of this can be, the dissolution of any of this can be controlled. If you control the dissolution of the drug molecule also, we can achieve a extended control release drug delivery system. If you control the dissolution of the reservoir membrane also, it can achieve a control release drug delivery system. Certain drug molecule, the molecule inherent property itself, the molecule's inherent property itself that it is low soluble or slow dissolution rate. An example of this type of drug molecule is, one is griseofulvin, second one is digoxin, nifedipine, etc. So this drug molecule has a slow dissolution rate. Because of the slow dissolution rate itself, the drug is slowly solubilizing in the fluid and slowly only it can enter into the system. That means the drug molecule itself is a controlled dissolution or controlled release system. So the drug molecule itself exists in a controlled manner. The second one is the drug that transforms in a slow manner. Transforms in a slow manner means drug once in contact with any of the GI fluid. The example is ferrous sulfate. If the drug is in contact with certain case of drug molecule, okay, certain drug molecules, once it comes in contact with the GI fluid, the transformation of the dissolution happens at a slow rate. This happens especially, it's only on the GI fluid. It may be different in other fluids. So once in contact with the GI fluid, this transformation happens or the dissolution happens at a slow rate. So the first class was the drug molecule itself has a slow dissolution. The second class is once in contact with the GI fluid, it dissolves slowly. So based upon these are the two different classes of or different mechanisms by which we can have dissolution controlled drug delivery system by controlling the dissolution of the drug molecule. Second one is slow dissolution rate of the reservoir membrane or the matrix system. So in this class, the membrane or the matrix is dissolving very slowly. If it is dissolving slowly means it may releases the drug also at a very slow rate. Now you can listen to this picture that is showing the slow dissolution rate of a drug molecule. So the first part, you can see a reservoir system incorporated with the drug molecules. The black spots, you can see the drug molecules. It's covered with a reservoir system or a polymeric membrane. The water molecule can be imbibed through this polymeric membrane into the dissolution system. And what happens, the entire drug molecules are not dissolving at a time, and it takes some time for the drug molecule to dissolve. So some drug molecules is dissolving, and the drug molecule that dissolve is slowly released out of the system or coming out of the system. So this slow dissolution of the drug is the one mechanism. In the second mechanism, slow dissolution of the polymeric membrane or the polymeric matrix. So here the slow dissolution of the membrane happens. In the previous case, the membrane is not dissolving, the membrane remains as such, whereas the drug is dissolving at a slow rate. In the second case, the matrix material is dissolving in a slow rate that helps in release of the drug from the matrix. So these are the two different categories under the dissolution rate controlled drug delivery system. Now, if we are looking into the mechanism or the principle of the drug release from a controlled release drug delivery system, the mechanism of dissolution or penetration of the drug molecule from the delivery system is called as flux. Flux that shows the permeability of the drug molecule or the permeability of the drug across as a biological or a non-biological membrane at a unit time through a unit surface area. So the flux is denoted by a letter J, and J is equal to d into dc by dx, where d is the diffusion coefficient and dc by dx is the concentration gradient. The concentration gradient denoted by dc by dx, and capital D is the diffusion coefficient. Instead of considering dc by dx as the concentration gradient, we can also have dm by dt considering the flow rate of the material, that is flow rate of the material with respect to time, that is dm, change in material with respect to change in time, dm by dt. And considering the area of the membrane, we can have the equation for the flux J is equal to 1 by A into dm by dt. So the first equation is based upon the diffusion coefficient of the drug and the concentration gradient of the drug within the system. We have the equation for J as d into dc by dx. Whereas considering the flow of material dm by dt and the area J is equal to 1 by A into dm by dt. Now we have another third more equation, that is dc by dx equal to cb in minus cs by h. So if the concentration gradient is linear and the thickness of the diffusion layer is h, so considering the thickness of the membrane as h and the concentration gradient, that is concentration gradient is what, dc by dx. So considering the concentration gradient that as a linear one and h as the thickness, again the equation can be modified as dc by dx is equal to cb minus cs divided by h. So this gives the third equation. Now combining these three equations, we can simplify. The third equation shows dc by dx equal to cb minus cs in divided by h. Substitute the third equation in the first equation, you will get what? J is equal to d into cb minus cs by h. That is J is equal to d by h into cb minus cs. Now again combining this with, so the second equation J is equal to 1 by A into dm by dt, you will get the final equation dm by dt is equal to dA by h into cb minus cs, dA divided by h into cb minus cs. So this is the general equation that representing the movement of the drug molecule across the polymeric membrane by the mechanism of dissolution or the dissolution controlled drug delivery system. Now the dissolution control release can be attained by two ways, either by encapsulation dissolution control or by matrix dissolution control. In other way, we can develop a dissolution controlled drug delivery system by the two techniques. The first technique is encapsulation method, second technique is matrix dissolution control method. Let us see what is encapsulation dissolution control. You know what is micro encapsulation. So in case of micro encapsulation has various techniques to perform the encapsulation, where the tiny drug molecules as being coated or the drug molecules are being capsulated inside in a polymeric membrane, or the drug molecules has been incorporated inside a polymeric membrane. This we call it as the micro encapsulation. That means in a micron sized drug molecules has been incorporated inside any of the polymeric membrane or a reservoir system. So you learned various techniques for micro encapsulation and how to perform the micro encapsulation, etc. you are aware. But the entire outcome of the micro encapsulation is development of a reservoir system where the drug is inside. Each drug molecule is coated with any of the polymeric membrane. So what happens is each tiny small particle of a drug is coated with any of the polymer system, and finally this encapsulated granules can be compressed, or it can be developed into a tablet, or it can be directly incorporated inside any of the capsule shell to develop a drug delivery system. So that is the way the encapsulated system works. We have various encapsulation methods like co-observation phase separation, interfacial polymerization, electrostatic methods, precipitation, hot melt, salting out, and solvent evaporation. For all these methods, we are using different types of polymers. That is, co-observation method used by or developed by water-soluble polymer, interfacial polymerization by water-insoluble polymers, electrostatic method by oppositively charged aerosols, precipitation by water or solvent-soluble polymers, hot melt by low molecular weight lipids, salting out by water soluble polymers, and solvent evaporation by solvent soluble polymers. That means the method of selection and the type of polymers are correlated. So either by using any of these methods, you can develop a micro encapsulated drug molecules, and these drug molecules can be further developed into a tablet, or it can be incorporated directly inside a capsule shell. Now this is a schematic representation or the graphical representation of percentage of drug remaining versus time. The percentage of drug, this is an in vitro drug release pattern. In vitro drug release pattern for the percentage of drug remaining within the delivery system after a period of time. So the y-axis shows the percentage remaining and the x-axis shows the time. Here the drug molecules has been micro encapsulated or coated. Another way you can say, simply for ease of understanding, you can use the word as coated also. Is being coated with various different percentages of coating material. The line A that denotes the polymer coating with a 17% coating, whereas B with a 15, C with a 13, D with a 11, and E with a 9, F with a 7. Okay, so from A to F, the percentage of coating decreases from 17 to 7. Now look into this graph. What you are understanding from this graph? Initially, in the A, if you consider the drug after 6 hours of time also, a major amount of drug or around 80% of drug is remaining within the delivery system. At the end of the 6th hour, a major amount of drug is remaining within the delivery system. But if you consider the F, within 2 hours, the percentage remaining came down to 0. A was coated with the 17% coating, F was coated with 7%. So A is the highly coated one, F is the least coated one. As the amount of coating thickness increased, if you have say the 17% coating means the coating thickness over the delivery system, the coating thickness over the drug will be high. If 7% coated means obviously the coating thickness will be very less. So as the coating thickness has increased, the amount of drug released get reduced and more amount of drug remained within the delivery system. But just opposite is the case. When the coating thickness is very less, more amount of drug has been released out, and within a shorter period of time the entire amount of drug has been released out of the delivery system. So this is the way how the coating thickness or the thickness of the micro encapsulation can affect the drug release pattern. So based upon the desired release pattern, we have to program our delivery system by giving or by providing various thicknesses for the membrane, various thicknesses for the rate controlling membrane. If you want a fast release, we can reduce the thickness of the membrane. If you want a very slow release, we can increase the thickness of the membrane. Next one is the matrix dissolution control. The matrix dissolution control, you know what is matrix dissolution control. So in case of matrix dissolution control, the dissolution or the drug release is being governed by various factors like rate of penetration of dissolution fluid into the matrix system, porosity of the matrix, presence of hydrophobic additives, wettability of the tablet, and particle surface. So in case of the matrix dissolution control system, the tablet is being made with any of the matrix polymers. Into these polymers, the dissolution fluid or the gastric fluid has to be slowly penetrate and it has to enter inside the matrix. Once it reaches inside the matrix slowly dissolves or it dissolves the drugs and it releases out of the delivery system. Now, the entry of gastric fluid may be restricted. If the gastric fluid is entering at a faster rate, this fluid can dissolve more amount of drug in the delivery system. If this penetration is less, very less amount of drug may be dissolved within the system. So this is the speciality of the controlling the penetration of dissolution fluid. So we can use different material, we can use different polymeric material that can have affinity with the water or that has less affinity, that has a high affinity. If it is having a less affinity means, it always keeps the water molecules, it always keeps the GI fluids away from the system without allowing the GI fluids to penetrate across the membrane. But if it is having highly affinity means, it takes up, the polymer may takes up the GI fluids and it can releases the drug out. So this way we can select the type of polymers, we can select the type of matrix material based upon our requirement for the release of drug from the delivery system. Then second governing factor is the porosity of the matrix. Obviously, even if we develop into tablet, the tablet surface will have certain pores. The pores which helps in imbibing the molecule, imbibing the water molecule, imbibing the GI fluids into the matrix system. So based upon the volume of pores, if the pore size and pore numbers, if the pore size is high or if the pore numbers are also high, more amount of water fluids can reach, it can release the drug very fastly. Presence of hydrophobic additives. As you know, these hydrophobic additives always keeps the water away. It repels the water away. It never takes up the water. This can reduces the release of the drug from our delivery system. Wettability of the tablet. This happens mainly because of the huge amount of hydrophobic additives. The wettability may be reduced because of the huge usage of the hydrophobic additives. If the tablet is wetting very fastly, that means it takes taking up the moisture, that means it is taking up the gastric fluid. Okay, so as the wettability is faster, more amount of drug will be released very faster. The last one is the particle surface. As you know very well, the dissolution or the solubility of the drug depends upon the particle size. So as the particle size is less, the more drug will be released. If the particle size is high, a less amount of drug will be released. So here also the release of the drug from the delivery system is again depends upon the particle size of your drug molecules. So this way, these are the various factors that governs the release of the drug from the delivery system made by matrix dissolution control. So this has a disadvantage that is the matrix dissolution control method has a disadvantage that the release rate decreases with time due to increased diffusional distance. Means the initial time point the release rate will be higher, good enough. As the time progresses, the release rate will be decreasing. The amount of drug released will be decreasing. So this is one of the main drawback of the matrix dissolution control delivery system, because the matrix never allows the water molecules. If you consider a 1 centimeter diameter tablet, so from the center it has 5 millimeter towards its perimeter, towards its sides. The drug what is present in the center of the tablet has to travel a distance of 5 millimeter from the central into the surface of the tablet. This distance we call it as a diffusional distance. So from the center of the tablet, it has to travel another 5 millimeter towards the edge of the tablet to come out of the delivery system. Whereas the drug molecule what is present in the edge of the tablet can easily jump into the dissolution fluid without any time delay, without any time gap. So what happens, in the initial time point, the release rate will be very high. But as the time progresses, the drug has to move from the center into the peripheral part of the delivery system, or because of the increased diffusional distance, the release rate will be reducing towards the end. So this is one of the main drawback of your matrix dissolution control delivery systems. Okay, so that's all for today. I hope the topic is clear for you. Okay, so just go through. Thank you.